So of course, the first thing we want to do at the end of our lecture is to really ask ourselves, what is the takeaway? What have we learned here? And of course, only you can answer that, but I encourage you to do that because it really helps you to structure your thinking. Then I want to encourage you to definitely write down what is not clear to you, because only that will help you to become a better student and a better engineer. And also think about what you will do to improve your understanding of those concepts. But last but not least, let's see if we check off all our boxes. I think we are there, and so we can know now that we understand what right-handed coordinate systems really are and why they are important for our systems and our operations. I can now also convert any given 2D x-coordinate system into a 3D right-handed coordinate system. That is kind of hand in hand with the first point. So if I understand that, that helps me a lot. I definitely understand what I, J, K are and how I use those from now on and how I use those to describe vectors. And then we learned about the directional cosine angles. We definitely know how to apply those. That is very important. So I can check that off for myself as well. And now I know how to include always 3 answers. So I always know that I need to include the 3 components in my answers. I need the magnitude, I need the components, and I need the directional angles. And by directional angles, we really mean alpha, beta, and gamma here. And so that is important for us to understand. And last but not least, we now understand the physical meaning of 3D vectors and the vector systems. So we can definitely effectively interact with vectors now in 3D space. That's why we will get a chance to practice it a little bit more on the homework, because it will be so important. And the first part of your homework is all about 3D force vectors. So let's take a look at those. Here in the first problem, you see just a hook or a system that holds onto 2 forces. And you can see that one of the forces is actually given by alpha and beta, whereas these angles here are given to you randomly in space. And so that is your first opportunity to really practice what we learned in this lecture. Then the next problem makes use of alpha, beta, and gamma. And here you really have to determine the angles so that the force along the mast has a force of approximately 50 Newton. And it says approximately here because everybody's F1 will be a little bit different. In fact, some of you might not be able to answer this question. We talked about this on other homework assignments. If that is not solvable for your specific variables, you have to explain why. And then maybe in this case, you even want to calculate it anyways because it's such a good preparation for an exam problem. Just make up your own number if your F1 doesn't solve this. But this should be solvable for most of us. So let's move on to the next problem. And here you are once again using alpha, beta, and gamma to really define the components of your force in the X, Y, and Z direction. And the angles are given to you here. So I believe that should be clear. Let's move on to the other subset of the homework problems. In those homework problems, you now use position vectors so that you actually define the lengths of some ropes here in this case. So the length of this rope here will be asked of you, and then also the distance between these 2 points in problem B. And same is true here for problem C, except now in problem C you're supposed to determine really the angle that is between this force and the x-axis. Be careful, this rod does not start at the origin, so therefore this angle here, although it's connected to the x-axis, is not equivalent to alpha. This needs to be calculated differently. You may want to set up a unit vector or something like that along this line and then find the proper answer here. Last but not least, my probably favorite problem in this homework set, because it can be either a problem that takes you 3, 4, 5 pages, or that can be solved within 2 to 3 lines. That depends on how effective you are with your methods and how well you understand the concept. So here you have a tower that is 24 meters tall, and you need to find the location for the anchor B. All the other points are given and the forces are given to you, so you need to locate the point B such that the system can actually be stable. And that is a very fun problem and a very engineering-like problem. Don't get me wrong, it's not the easiest problem in the homework. That's also why it's the last problem in the set. But it is something that you definitely want to study and have fun with, because this is true engineering. And with that said, I wish you good luck with your homework. Have fun practicing all the knowledge that we just discussed here in this lecture. And then I will see you for our next topic in our next video lecture.